Welcome everyone. Let's look into a problem from JEE 2006 and see how similar it is to a problem from a book by Savchanko written in 1977. Okay. So let's look at the JEE problem first. What does the JEE problem says? That there is a binary system of two masses, okay, which is rotating around its center of mass. MA and MB are two masses, and the distance from the center of mass is RA and RB. So we need to determine the ratio between the time periods of two bodies. First and foremost thing, you do not need to solve it by writing anything. Just think about this. Because it's part of a binary system, the rotation will always be at the center of mass. That means two bodies will always be at the end of the straight line and with the center of mass in between. So if it rotates, right, what will happen? It will always have the same time period because it's part of a single body now. If it has same angular velocity, that means it has same time period, right? So what will be the ratio of two bodies? 1. Straightforward. Now, if you are asked to provide a ratio between the velocity of two bodies, between the radius or mass or omega time period, all this can be just simply solved verbally. You do not need to actually pick your pen and paper. Now, when you actually need to determine the actual value of time period, which now we are moving into the Savchanko. Okay, so what does Savchanko problem is asking? It has similar setup. Only in place of MA, MB and RA, RB, it's saying M1, M2 and the distance between both the bodies is R. But I've considered it R1 and R2 for the moment. That means what is provided? First thing is provided as R1 plus R2 is equal to R. Now what it is asking? The time period of these bodies for rotation. Now we know time period will be same. So another thing that we know, T1 is equal to T2. Simple, right? So if T1 is equal to T2, that means if we only work on one single body, that will give us the answer. So first equation that we should look into is how to actually relate R1, M1, R2, M2. So we will use the center of mass concept. Center of mass concept says M1 R1 is equal to M2 R. Okay, great. What is the second thing? If you look at the force on the body of one, what it tells you, there is a gravitational force inside, and also there is an centripetal force. Okay, centripetal force. Both of them are working towards the center. So how to actually then balance the force? Then we have to go into the non-inertial frame and consider the impact by centrifugal pseudoforce. But we know that Fg that is acting between these two bodies, M1 and M2, in a straight line is always same for both the bodies. So we can simply say that Fg is equal to G times M1, M2 by square of the distance between them. And what it will be equal to? It will be equal to the centripetal force, which is now being considered as centrifugal pseudoforce. That is what? That is equal to M1 omega square and R1. So I can simply say M1, M1 gone. So my omega square equal to G M2 by R square and R1 as well. Now, if we get the value of R1 with respect to R, then we get the actual time period. Okay, so let's look into it. So if this is my first equation and this was my second equation, so looking at the first equation, R2 by R1 equal to M1 by M2. Now add 1, 1 on both sides. So what it will become? So this becomes R2 plus R1 by R1 equal to M1 plus M2 by M2. So what is R1? R1 is equal to M2 divided by M1 plus M2, and what? This is equal to R. This is R. So we got the relation. Now let's put this back in this equation. What it will be? So my omega square, putting it in this, it will become G M2 by r square, and if we just put r1 here, so this becomes m1 plus m2 divided by m2r. So m2 cancels out. This becomes gm1 plus m2 by r cube omega square. So what will be the time period? Time period will be 2 pi root of r cube by g m1 plus m. So if you solve a problem from a good book, actually it always gives you an edge for solving complicated problems in competitive exams. Okay, thank you.